What's up, Pre-Ace Physics? I thought it might be helpful for me to do a quick little video about moments for you, just a sample problem. So what we got going on here is we have a bar that's at equilibrium, and this bar is 8 newtons in weight, and so I've marked the center of mass, and there's the 8 newtons. On the bar, we've got these two objects, which weigh 6 newtons and 4 newtons, respectively. And then the bar is being held up by these two supports, and I'm going to try to solve for the force that those supports are supplying. Okay, so the first thing I'm going to solve for is F sub y. All right, and so to do that, I'm going to take moments about F sub x. Okay, so I have this guy right here. He's providing a clockwise movement. This guy is providing a clockwise movement, and this guy is providing a clockwise movement. So we have a 5 by 6 plus a 9 by 8 plus a 13 by 4 in the clockwise direction. Add those guys together and you get 154 Newton meters. Now, that has to be balanced exactly by the anti-clockwise movement. So again, I'm taking my moments with respect to that point right there, that support. So the only anti-clockwise movement I have is from the other support. So that distance is 18 meters, and then that's by whatever the force is that I'm solving for. So my anti-clockwise is 18 by F sub y, okay? Since this is at equilibrium, you have to set the clockwise and anti-clockwise equal to each other. And then when you solve for F sub y, you get approximately 8.6 newtons, okay? To solve for the other unknown force, F sub x, okay? So if I'm gonna do that, I'm gonna take my moments about F sub y, okay? So I have an anti-clockwise movement, an anti-clockwise movement, and an anti-clockwise movement. And those guys are 5 by 4, 9 by 8, and 13 by 6. Add those guys together and you get 170 Newton meters. Okay, I've only got one clockwise movement or moment. Okay, if I'm taking moments about F sub y, and that's this guy right here. So that's 18 meters by whatever that force is. So here we are. And again, if this is at equilibrium, the anti-clockwise and the clockwise have to be equal to each other. And then solve for F, the force at X, and you get approximately 9.4 newtons. All right.